Okay, so the last thing that we were doing was factoring a GCF and the grouping method. Now we're going to go into section 6.2. 6.2 has to do with something that I call the shortcut method. The shortcut method is basically where we're going to have a trinomial. Trinomial just means that we have three terms. But what makes this special is that you cannot have a leading coefficient. So notice there's no number here. Okay? Some of you might say, well, isn't there a 1 here? Yes, technically there is a 1 here, but I'm talking about that there's no other number that you see here. You don't see a 2, a 3, a -9. There's no leading coefficient here. So if there's no leading coefficient and you have three terms, we can use something called the shortcut method. Now, before I actually do the shortcut method, remember, your first step in any type of factoring is that when you have any type of factoring, you must see if there is a GCF. In this case, we have three terms, so let's use all three terms to see if there's a GCF before doing any other type of factoring. We talked about GCF, remember it's A through D. A, do we have matching parentheses here? No. B, do we have the same letter in every single term? No, this third term does not have an X. C, do we have a number factor in each term? Number, ooh, no number. So we don't have a common number factor. And D, does the polynomial start with a negative? No. So we know that we cannot do GCF. Once you do that, part 2 was always to count how many terms that you have left over. Since we didn't do any GCFs, all this is left over. Notice we have 1, 2, 3 terms. Remember, if it was 4 terms, we did the grouping method. But when we have 3 terms and no leading coefficient, then we're going to do the shortcut method. Now, what is the shortcut method? Well, I wrote out the steps here, and it will be as a picture on the announcement. But you can see here, it is a little bit heavy. It's 6 steps, but the 6 steps are pretty easy to go through. Your first step is the setup, and that's where we're going to use 2 sets of parentheses, and each of the parentheses is going to be a binomial. You're going to take that leading term that you have in the trinomial and just break it up evenly. Remember, if you have x squared, x and x would be breaking up evenly. If it was x to the 4th, that means you do 2 x's here, x squared, and 2 x's here, x squared. The second step would be the sign of the binomials. You need to have a sign here and here. They can either be pluses or minuses. So to determine what type, look at the last sign of the trinomial. If the last sign is a minus sign, we're going to use different signs. That means 1 plus, 1 minus. I always put the plus first and here the minus, but it doesn't matter. As long as one of them get a plus sign and one of them get a minus sign, you're good. If the last sign of the trinomial is a positive, that means these two have to match. They have to have the same sign. Either 2 positives or 2 negatives. When you look at the middle term of the trinomial, that will determine what pair. If the middle coefficient is a negative, then these will both be negatives. If it's a positive, of course, these would be both pluses. The third step is a combo list. Basically, what I want you to do is take the last term of the trinomial and think of all the 2 numbers that you can multiply that will give you that number. You're going to write each of the different combos in a list. I suggest to go in order, start with 1, and work down. The fourth step, once you get your list, you're going to either have to add those lists or subtract the list. And that's based on the last sign of the trinomial as well. If you see a plus sign at the end, that means we're going to add the combos. If you see a minus sign, we're going to subtract the combos. Once we get the addition or subtraction going on, the 5th step says choose a combo. So whatever total that you got from step 4 must match the middle term of the trinomial. Whatever combo gives you that middle term, great. And then placement of the combo. Once you choose a combo, remember, we might have a 2 here and then a 7 here, or you could have a 7 here and a 2 here. The placement says take the higher number, and that will always get the same sign as the middle term of the trinomial. So those are 6 steps. They'll make more sense once we start doing a few more problems. So let's do this first problem here using the 6 steps. So I have x squared plus 9x minus 36. We already said no GCF, definitely shortcut. So step 1, setup. So let me draw my 2 sets of parentheses. And I break out this leading term. Now notice there'll never be a number here because the shortcut method says that there cannot be a leading coefficient. So you're just breaking this out evenly. Remember, squared means that you have 2 x's. So 1x will go here, 1x goes here. It's always going to be xx for x squared. If this was x to the 4th, then it'd be 2 and 2, x squared, x squared. The second step, we have to look at the last sign of the trinomial because we know that this and this must have signs. Now look at the last sign here. Notice it's a minus sign. That tells me I'm going to have to use different signs. Different means they're going to be opposite of each other. So it's always going to be 1 plus, 1 minus. See how they're different from each other? So anytime you see the last term of your trinomial minus, always 1 plus, 1 minus. Third step. Third step is to take the last term, the 36, and get all our combos together. Okay? So combos would be, think of 2 numbers that multiply that give you 36. This is different than a tree diagram. A tree diagram, you want to get all prime numbers. Here, I don't care. I want you to think of any 2 numbers that multiply that gives you 36. Now, I told you as a hint, when we do the combos list, you always want to start with 1. 1 will always work. The reason why, 36 divided by 1 is 36. You're thinking of everything that you can divide in evenly would be a combo. For example, 2. 36 divided by 2 is 18. 36 divided by 3. This way, if you didn't know the combination of 2 times 18 or 3 times 12 gives you 36, if you go in order and just do it in your calculator, 36 divided by 1, 36 divided by 2, 36 divided by 3, you're going to find all the different combos. So 36 divided by 4 is 9. 36 divided by 5, doesn't go in there evenly. If you put it in your calculator, you get 7.2. When you're doing a combos list, you're only putting the numbers that go in there evenly. No decimals, no fractions. So 1 through 4 worked, 5 didn't. Keep on going in line. 6. 36 divided by 6 is 6. How about 7? Nah, you get a decimal point. 8? Nah, you get a decimal point. 9? Yes, it goes in there 4 times. But notice it's already up here. 4 and 9 and 9 and 4. Once you repeat a combo that's already on the list, even if it's out of order, 4 and 9 versus 9 and 4, once you repeat a combo, you're done. You don't have to say, well, does 10 go in there evenly? 11 goes in there evenly? Once we hit a repeat, you got every single combo that makes up 36. Once we get our combos list, we got to do something with that list. Step 4 says we're going to either add or subtract the list. So we got each 2-digit combo. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 with 6. Notice the last sign of the trinomial is a minus sign. That means we're going to subtract each of these combos here. So when I subtract, I get a 35, a 16, a 9, 5, 0. If this was a plus sign, then we would have add the combos. Okay, pretty simple for step 4. Step 5. Now I got to choose a combo. One of those totals that we just got, 35, 16, 9, 5, and 0, one of those must match the middle coefficient of the trinomial. See the middle term? There's the coefficient of 9. Let's see, did anyone give us a total that's 9? Yes. That's our winner. We can ignore every other combo up here except for the 3 and 12. So now I chose a combo. The last step is placement. Because we got a 3 and a 12, do we put the 3 first? Or do we put the 3 over here? To determine where the 3 needs to go, our last rule. Take the higher number combo, so out of 3 versus 12, 12 is larger or higher, it's going to get the same sign as the middle term of the trinomial. So we already told you 12 is the higher number, the middle is plus. So that means the higher must get the positive sign. So the 12 can't go here because that would make it negative. The 12 must be here. Because remember, higher number has to get the plus. That means the 3 will go over here. If you did another rectangle and multiply this and this, you'll get this answer exactly. So this is your factor. X plus 12 makes up one binomial, and x minus 3 makes up your other binomial. And that's how to factor this trinomial.